All right, sorry about that. We're trying a different program here to see if we can record a little easier. I still have this weird feedback echo in here, but we'll deal with that. So, trying to come up with a way we can catch everybody back up. A couple of things. I see some people missing some assignments, so if that's the case, and you'd like the chance to make them up, and they're ones we've already turned in, not obviously with you two, it's not as big an issue, but email me and I will come up with an alternative point assignment. So if you're missing the ones for chapter 4 or chapter 5, you'll see we turned in some stuff the other day. I did a recording just to see what would happen using this software if you want to go see what it is. It's kind of an interesting product called Screencaster. Seems to work a little better than the Adobe, at least here in this lab for whatever reason. Part of it is it records a local copy instead of just a copy on the internet. So we've looked at nested loops now. We've looked at how do we do arrays, which are probably the most powerful thing we can do. And now we need to think about how are we going to reuse this code. And I've talked over and over and over again about the idea of this modular code and how we're going to reuse it. And when I did that, testing, there we go. Okay. One of the things I did was we looked at how do we reuse code? And I keep talking about this idea of modularity, taking a piece, using it over and over and over again. And we can do that. We can do that in our program pretty easily by just copying and pasting. But there might be an easier way to even do some of this. And so we're going to come up with a method, pun intended. So we're going to come up with a method that we can reuse code, and we can use it instead of just copying and pasting. We can actually create some form of a subroutine, if we want to call it that, some way we can reuse existing code over and over and over again. So we're going to talk about modularity, what a scope is, and then these ideas that we're going to look at. How do we use something over and over again? How do we create a method or a module that returns a value and what that advantage is? And then how this leads to the idea that we can use these libraries that are already existing. So what we really want to do is create little modules. And there's not really any different than the modules we're going to plug into our code, but there's a couple of things that we want to be able to make happen. A, it's silly to duplicate things over and over and over again. So if we want to print something on a printer, does it make any sense to rewrite that code to print to a printer every time we write a program? No. In most cases, we want to be able to write something that other people can use. And if we're creating an object or a program or some kind of thing we're doing, are we the only programmer working on it? So how many programmers do you think worked on the Macintosh operating system? How many do you think worked on Windows 8? Probably thousands. In fact, some pieces may be contracted out. So how do we connect all those dots? And so we have to create these modules. Now, one of the things we want to do is make them standard enough that we can use them in almost anything we want to do. So we want some standards we're going to develop. And so instead of a big program, so Windows 8, if one person were trying to develop that, it would take forever. And maybe it would come out better, I don't know. But, so we can connect these modules, we can link to these modules. So what we're going to talk about come under a whole ton of different names. So what we're really referring to is the same thing. So depending on which language or what your exposure has been, you may call them a module, you may call them a function. And if you think back to your math class, that idea of that function, we put it into a box and something comes out of a box, that's really what we're doing. So you may call them a subroutine. So to invoke any of these, we really just call it from our program. So somehow we call this. So depending on the language, some of the syntax may be a little different, but we say we're going to run module print. So we can generally have unlimited numbers of those, and not only can we have unlimited numbers of these modules, we can use the same module over and over and over again, and that's one of its powerful advantages. And depending on what type of module it is, that module can sometimes adapt depending on what the information is we send into it. And so we'll talk about this idea called polymorphism more and more as we go along here, so that we want to write these modules so they can handle multiple details. So for example, let's talk about our print module. If I wrote a print module, but the print module could only take Chinese characters, that's not really very useful except in a specific application. However, if I wrote that print module so it could take any type of Unicode character and print on the printer, or it could take a graphical image and print on the printer, that would be far more useful, and it doesn't care. So when I call module print and I pass in a document, I don't have to worry about what document I'm sending it. So I could send it a Word document, I could send it a Notepad document, I could send it a text file, I could send it an Excel spreadsheet. It doesn't really matter, because that code in that module will grab that, whatever it is we sent, and still print that. So that makes it easier for us then once we get to that point of writing these. So these modules do a couple of things. We don't have to have them. So if you look back at old programs, these weren't that common. So if we go way back to the original coding, yes, we had pieces that we'd run over and over again, but not to the level of this black box abstraction like we're looking at today. So we don't care. In other words, that abstraction, we want to be free of the details of that. So once we write that print module, we're done with it. All we're going to do is invoke it. We want to make it easier for multiple people to work on the same program, or to expand or change, or even for us to go back in and modify or change our program. And we want to make it as easy as possible for us to reuse our own work. Because quite frankly, we're lazy. I know. Don't look at me that way. We're lazy. We don't want to do any more work than possible. Right, Michael? Michael's like, yeah, damn straight, I don't want to do any more. But by doing that, so if we write things correctly the first time, and we use this idea of these modules, we can then have this whole library of those modules. So programmers will have modules, and in fact, some of these then become built in. And you'll start seeing when we work with Python, there's libraries that we can tap into, so we don't have to write those print modules. Or we don't have to write like the IP address module that handles some of these IP addressing and other schemes. So this idea of modularization makes life easier for everybody. So abstraction. So in other words, we don't pay any attention to the details because those details we've already worked out. So it allows us then to concentrate on our main material. So most of you have written a research paper. It's the same idea as now there are tools, including the latest versions of Word, that can handle some of the details of your research paper. And those things like footnotes and sources and citations, you put in them once and then you can grab and use them over and over again. That kind of level. So hopefully this gives us a tool. So modules give us a way to provide that abstraction. And we really like now, or at least in some cases, these high-level or more English-like programming languages. So we don't have to write individual instructions to flip individual zeros and ones. We write something that says, create a loop and do this. and it does all the logic behind that for us. And so these modules are kind of a handy, convenient way to do that. Move this just a little bit here. All right, so the reality is almost all of these we could just cut and paste, but it makes it a lot uglier. And when we start getting thousands and thousands of lines of programming code, we want to make this as easy as possible. So quite frankly, some very complicated programs now, and in fact some we're going to write in here, the code itself, so where we go from start to end, if we want to think about it that way in our pseudocode, maybe only 10 lines long, but what it does is call 5 different modules, and those modules may be thousands of lines long. But it makes it an easy, quick way for us to understand what we're doing. So, and again, it's that idea of how do we divide up the work. So, quite frankly, most programming is now an effort. The other thing that really happens in a lot of cases is we contract out a lot of this work. So if there's already modules that are known to work, so print modules, and I'll just keep going back to that because that's one that almost everybody uses. If there's already a predefined print module, everybody knows that it works, or we assume that it works. It's predefined, maybe it's already gotten some certification, so if we worked in a power plant or other industry that's got some certifications to it, those things are pre-certified. We know it works. So it gives us that idea of reliability. So we know that it's been working, so we can reuse it, it's reliable. So when we talk about math functions, for example, we come up with these quite often. So I said we could have a main program. So the main program has the logic, and all it really does in some cases is we feed it into these modules. By some of our definition then, our method or our subroutine or whatever we're going to call it has a couple of things. So it's got a header, and that header then tells us what it's going to do, identifies that module, and depending on the different programming language, that may include the name of the method, in other words, where we call to. We have a body, in other words, all those statements that execute whatever it is we do in that module, and then a return statement. And the return statement does usually one other thing. So that return statement returns it back to our mainline logic. The other thing it does is it lists generally what we return with it. So not only do we return, so if I send a print statement, we don't return anything. A print statement generally says, okay, there's nothing really to return. But if I do a math function, and I'm saying to a math function called divide, and I send 2 numbers to divide, it'll return a result. So there's generally those pieces, and I'll show you very quickly what we're talking about. So here's some programming logic. So if I look at this, this kind of looks ugly. So we have a start and we have a stop over here if I'm looking at the pseudocode on the right. And so we're making a question of, is B true or false? Yes, and it's got a set of instructions. And then we come down to, is G true or false? So we've got another if, then, else statement. So this works. But is there an easier way to break this down? And especially if we're going to reuse this logic. So maybe this is asking the questions about anything. Is a student enrolled in Peru State College? Yes. Have they paid their financial aid deposit or rent deposit or something else? So we want to look at, are we going to reuse it? So the first question we ask is this a piece of our code that we're going to reuse? And if we're not going to reuse it, Is there an advantage to putting it into a method or a subroutine? So it sometimes becomes a question of where do we divide our work up. Now, what I'm going to tell you today, for the most part, unless you're on a very, very large scale project, the reality is that our computers are faster than we are. Some of these things that used to be true even 5 years ago are not necessarily true, depending on what device it's going to be on. So if I know that this is going to be used mostly on business computers that are fairly fast, I probably don't worry about the fact that if I put these all into methods, that can slow a program down a little bit. But most programs are so fast, and our computers are so fast. Even the reality now, our phones. We've even got to the point where phones are so fast that it's not as big an issue. It used to be a little more of an issue. There are a few specific places that this still falls into a question. So if I'm writing software that is very dependent on timing, so video or voice over internet software may be an issue where we look at that. The other weird issue is high performance gaming. And so sometimes in our games, we look at, do we want to write these in modules or do we incorporate it back into the mainline program to speed up play for whatever reason? So those are kind of two of the areas that we look at. So we're looking at this idea, and we have this term cohesion. So the more statements in a method that contribute to the same job, the greater the functional cohesion. In other words, what we're saying is we're trying to get everything in that module to contribute to the same output and desired output. We could do extra things, and we try to avoid that. So our method for printing, we could add modules in there or pieces to add and subtract and do all kinds of other things, but that doesn't make it cohesive. So what we want to do is make it as functional as possible and as streamlined in terms of what its specific focus is, if you want to think about it in those terms. So we want cohesive. In other words, it makes sense. So we have a very short program, and we think, well, why are we going to reuse these pieces? So we're going to display 3 address lines. So all our program in this particular case is going to do, and it's going to have one statement that's going to call the method, rather than 3 separate print methods. Now, this may seem like a silly example when we start looking at it, but what it does is shows that structure. So we're going to create something here called the name and address. And one of the ways we generally tell that we're calling some kind of a function is we have a name and then we have those parentheses open and closed behind it. So you've all taken 101, C-minus 101, right? Okay. How do I get the current date into an Excel spreadsheet? Oh, you guys are like, really? We're supposed to remember stuff? Okay. Just out of curiosity, go ahead and open up Excel on your computer. So, just a blank worksheet. How do I get the current date in a cell? That seems like something we do quite a bit, wouldn't it? So I want to get the current date. So we know it's probably a formula of some sort. So in Excel, if I type in a formula, what do I start in a formula with every time? Equals. So type equals. Okay. Now, we have a method or a subroutine in Excel called now. Now tells us today's time and date. So type equals now, and then notice I have to put in the open and close parentheses to make it work. And that says, hey, it's a function. If I hit enter now, in that cell, it gives me a return value. So even this nomenclature that we're going to use works in a lot of different places. So that's a function called now. And that open and close bracket, we didn't put any values in there, did we? But other functions we use, we do. So if I type equals sum, and I do an open bracket, or open, yeah, there you go. Notice it's asking for some kind of details inside of there, right? So depending on what we're doing, that just shows that we're either passing no information. The equals now doesn't need anything. It's just returning a value. But the sum function requires us to put in some information to pass into that module. So even if you haven't thought about modules and how to use them, you've used them just in another particular way. So our logic here. So we're going to start, and we're going to have a stop. So if I look on the right-hand side, our program is actually between the start and the stop. And then our function, that name and address function, module, whatever we want to think about it as, is actually down below the main program. So we declare, we have something called a string name, we have a number, we have a set of strings named line 1, 2, and 3. We input name and balance, and then we call the function name and address. And that name and address function then jumps down, grabs this function where it says name and address, outputs 3 lines, and then returns. And when it returns right back to the previous spot. And so then we go to the output of customer, and then total. So with all the other information we're displaying, that seems kind of silly, doesn't it, to do that? It's really just showing us how we can do this. So there's a lot of other things that we can bring into play here. So instead of if we just had one customer, imagine that those were an array. We could reuse that module to output customer names. So think about when I create a mail merged letter. You guys have all got the ones from the alumni department already, probably saying, hey, as a future graduate, we'd like you to donate to the college. You guys got those yet? No? You will. Those are done with that idea of a mail merge. They have a list of addresses, and they call a subroutine that grabs an address, puts it on an envelope, and then returns back to the main program and says, are there more addresses? Yes. So let me send that one down. So that's all there is to this idea of creating a module. And so that module, then, we can use it over and over again in the same program. We can use it in a different program. So here's where it starts getting a little tricky. Is the idea of something called scope. And scope is the idea of where these particular things are, like our variables, are visible or usable. So if I declared, so if I go back to that method and I declared a variable inside that method, and so when we get more complicated, we may have loops, for example, inside of our method. We may do all kinds of other things. If we do that and we declare those variables inside that method or that module or that subroutine, they're only available inside of that subroutine. If I declare them in the main program, they're available in the program and in that subroutine. So it depends on what our final outcome is. So if I'm declaring a loop with a for loop with for I equals 1 to 35, it's probably fine to declare it in that module. If it's a variable that I need to pass from the program into the method, I can't declare it inside the method. So we can have local, in other words, they're only available inside that module, or they're global, in other words, they're available to the entire program. And so we have to think about in terms of where that variable and what it's going to serve, how are we going to use it, and right now we want to talk about it in terms of usability. A little later we'll look at it in terms of security. So there may be times when we don't want the variable social security number, for example, available to anybody that logs in and is working on a system. So we may want to restrict its scale. Right now we're looking at how do I use that data? And how do I then declare it? Because one of the things we haven't looked at yet is, can I declare from one module to launch another module? Does your head hurt thinking about it? Michael's like, yes. So I could have a module that said address lines, like we did before, and then at the bottom of that address lines module, after it prints those three, it could have another link to another module that said print stamp or something, if we were able to do our own prints. So we have to think about in terms of how and where do we want these variables to be visible. So local. They're not known to other programs or other modules, depending on which ones they're in. They're available only while the program is running. They're not passed off to the operating system or anything else. And they're stored inside of an area that the program controls or the method controls. So that big array, so think about our problem the other day when we figured out that we could have 1,050 students, and we created that big array. When the program shuts down, all that data is gone, right? It doesn't get passed to any other program. Global, though, says that those are known to the entire program. And then we can even have ones that are created outside of our program. So in other words, we're pulling data that's existing. So our program may pull data from Windows, so that's an even bigger environment than our module or program. So we can declare them at the program level. So in other words, that entire program has them. And we have the term encapsulation. So what we'd like to do in most cases is we want to encapsulate that data. In other words, keep it to that method, keep it to that program. We don't necessarily want it to be available for other uses most of the time. And so a lot of that has the idea about security, about keeping that data integral. In other words, we don't allow it to be modified by other programs. So if I need a program or a piece of data that I'm going to use throughout the entire program, I can declare it globally. So in other words, I can put it in the beginning of my program and say, hey, I'm going to use this every piece of my program. We do that with some variables, and it really depends on the program. Traditionally, if you worked with Visual Basic or some of these other ones to start with, that's the way almost all the variables work. But what we're finding as we do this object-oriented is we try to keep them in that individual blob or that module or that smaller piece. So, we opened up Excel and we looked at something called the now function and the sum function. So the now function, did it require anything to be passed in those parameters? No. It just took a data and returned it to us. So anything in those parentheses, though, is something, a value that we're going to pass into that function. Now, they call it this phrase, argument to the method. It's really just the data you're passing in to that method. So, what we're talking about is we're passing data directly. So, we call it passed by value. In other words, you're sending a copy of that data. So when I did the sum, and you'd put in 35 plus 42 or whatever, you're passing in data directly, or a list of values. In some languages, we get to do something else. And that's a little weird, and it's called by reference. So this makes sense. We can pass in an argument, but what I want you to think about is when we do that, so I pass in that value 35, it becomes stored two places. So it's stored, the original value of cell A is stored in the original spot. And then when we pass in that value, we create a second copy of it that's stored inside that method. Wherever that method creates a pool of data to store it, it creates a second method. So that's pretty good for most things. Now, can you think of anything that there would be a bad thing for that? Why might that be bad to pass a second copy or create a second copy? What if we are looking at, let's think of something very large. So what we're creating is a DVD player app. Do we want to create a second copy of that entire DVD to pass it in? Kind of an absurd, because we know the DVDs are broken into pieces, but even those files are very large. So sometimes, because of the size or other requirements, we pass in a value that really says this is where this item is stored. In other words, we pass a link to the location. So rather than create a duplicate copy of that DVD or a song or a picture, we pass in a link, so we pass in a reference that says you can find this at address 371219 or wherever it happens to start. And so we pass in information about where it's stored and what's stored there. So for almost everything we're going to do, we can pass in a value. But when we start getting larger and larger and larger, sometimes we want to pass in that reference method. And there's some other reasons we might want to do that. So if we're writing a secure system that's dealing with student information, we might want to do that reference method because we don't want to create copies of things like student IDs. So sometimes we do it that way. So essentially there's two ways. We can pass in the actual data, or we can pass in the location of where we're going to go with. We can create a function or a method or a subroutine that takes more than one piece of data. So if you still have Excel open, Excel is a good example of this idea of functions. So let's look at, just out of sheer fun, if I type in equals if. Oh, now I open a parenthesis, so it'll start telling me. Now if I notice, when I do that, can it and does it expect more than one value in there? Oh, okay. That's the same idea we're talking about here. We can create a function that takes more than one piece of data at a time. So we may do that. So think about our outputting a list function. We may output name, address, phone number, zip code, all of those things, all in one argument. So the one caveat I'll warn you about is when we do that, we're passing in those data items in a list separated by commas generally. The computer's pretty dumb. Pretty dumb. It is worse. I don't even know how we can describe it as being worse than. It can't tell anything other than the order you put them in. So one of the common things we do is screw up that order. So if we say it's going to be name, address, city, zip code, and we do that in any value out of order, it's going to cause us an issue. So we have to make sure that our method, where we take those values, they're in the same order as the argument when we pass them in there. And I know that seems silly. You go, well, why would I ever screw that up? Well, it happens. And so that's one of the issues with this modularity, and why when we do Excel, when it opens up that equals if or any of those functions that takes multiple arguments, it gives you that big hint and says, hey, this is the order they need to be in. Because we're hopefully writing this module, so once they wrote that equals if module, nobody's going back every day and changing that. It's set, it's standard. So we want to make sure that those parameters then, we know what they are and we've listed them. That's a good place for even comments, you know, hey dummy, make sure you put them in this order. And so that way when somebody else wants to use your output module or your input module or whatever we're calling it, they know how and what order these values need to be put in. And then, so we've talked about how we pass data in, and now we need to look at how we get data back out. So I'm actually going to jump to the bottom of this slide. So in the middle of that slide, it talks about a method can return nothing, in which case the return type is typically indicated as void. Huh, okay. So technically, although we got a date out of it, that equals now when we just do a parenthesis and close parenthesis, that's telling us that we're not technically returning anything, or it's a void method. Even though we got something back. So what types of data do we return? And if we put in 3 arguments, do we have to return 3 arguments? No. We can return 3, we can return none, we can return 5. It's how we've written that method. So this encapsulation piece lets us create those modules or use modules that are existing, and we don't need to know anything about them. All we need to know is what data to pass in and what data to expect out. So we can think of these, once they're done, as a black box. We put values in at the top, something comes out the bottom. And we don't necessarily need to know or care even then what's going on the inside of those. So almost every language now has some of these methods that are already been written, already done. They're called pre-existing libraries in most cases. Some of them are just explicitly built in. So you don't need to worry about how to create a program to add 2 numbers together, or how to get today's date, or how to sum 2 numbers, or how to do an if then else statement. Those things are already predefined. So you can work on the business logic. In other words, how my program is actually going to operate. Now, where it gets a little trickier is you'd think every language would call these things exactly the same and work exactly the same, and it doesn't. So you'll see that when we work with Python, Python's libraries work a little different than C++, which work different than Ada and some of the other languages. So there's built-in libraries, great. And we may have to go back to that language, that documentation. So if I need the most authoritative source for documentation on Python, where do I go? Where did you go to get the program? Python.org. If I need authoritative information about another language, I may find places that are very authoritative and list all those. So the other place that we can then get some of these methods is there are a lot of third-party sites. So there's a ton of modules built in for Python, for Ruby on Rails and all these things. We can add library extensions, and then we can even go out to places like Dynamic Drive, other places that license software, and we may be able to find a method or a implementation for what we want to do. And so sometimes we'll do that. So maybe our program, the main goal of our program is accounting software. And we wanted to add a module in there to play a CD for soothing music, because we figured that our employees, as they're entering data for an accounting software, if we could give them some soothing Yanni music. Does everybody know about Yanni? Yanni. Don't look like... We'll have to listen to it in class for an hour. So if we created a module to play a CD so that the clients, as they're entering data, are in a happy state, they're putting in happy numbers. But here's the problem. My programmers don't have a lot of time, and I said, you know, I need to implement that function today. You can go out to places like that Dynamic Drive or other drive libraries, and the reality is somebody's already written code to play a CD. And we can then implement that as a method inside of our own program. So we walk on the people that have already done this. So you're going to create, at the beginning, we're going to create some very simple hello programs to teach you how to look at that. But once you start getting more advanced, this is the one class I'm going to tell you where copying and pasting is a very good skill. If this were research methods, I would not say copy and paste. Here, copy and paste using existing methods, I expect you to be able to do those kinds of things. So, when I use a method, something else, a program, subroutine, whatever, I need to really know what it does in general. So if I think it's going to play a CD and what it really does is generate fractals across my screen that I can't do any other work, probably not a useful module. So I need to know what it does, what its name is, in other words, how do I address it and call it, what are my required parameters, in other words, what do I pass in, and what gets passed back. Okay. Now, I'm going to disagree just slightly with this. What I don't need to know is how it works. And 5 years ago, I would have said yes. But here's something sad that's happening. So these libraries that come with Python and at python.org, safe. I start using methods or things I find out on the web, not necessarily so safe. And so sometimes I need to be a little cautious and make sure that I do understand what those methods are implementing. Because there have been cases where people have implemented modules that were, in theory, supposed to print or whatever. What they've actually done is they've got pieces of code in there that actually intercepted things like print jobs and sent them to third-party sites. So we do have to be a little careful about that. That's just the security paranoia side of me saying that. Because there's some things people have managed to tuck in a few short lines that we didn't realize were in there. So modularization gives us the ability, so we can eliminate work. In other words, I know I keep mentioning this lazy, but programmers are lazy. If you're not lazy, you're not going to be a good programmer. It doesn't mean a nap, Michael. You're like, oh man, I could take a nap. But what I'm saying is you don't want to do things over and over and over again. So the same skills that make somebody a really good football player out there running drills over and over and over again are different than what makes a good programmer in some cases. Because what we want to do is eliminate repetition. If we have to do something a couple of times, well, maybe we can come up with a method to stop that or make it a little easier to deal with. So we want to make it eliminate repetition. So if I'm going to do something over and over again, if I'm going to do it for multiple times in that program, if I'm ever tempted to copy and paste in a program a set of lines of code because I need to do something, I'm thinking about, man, maybe I should make that a method or a subroutine to run that. So it makes it easy to reuse our work. It makes it others easier to use your work. So essentially it has three pieces, a header, a body, and a return, and that's it. So we do have to remember that idea of scope. Where is that variable or that data visible? And so for the first things we're going to do, a lot of times we write them globally. In other words, they're visible to the entire program. As that program gets bigger and bigger and bigger, there's times when we want to say, you know, I want to make this available but not to the entire world. So if I think really abstractly about that, my small program to play Minesweeper, and we've all played Minesweeper, right? The details in Minesweeper don't need to be passed outside of Minesweeper, correct? But the values that are in the Windows 8 operating system to run Minesweeper may need to be passed in a much larger environment. So we think about in terms of scope. We can pass data two ways, or pass an argument two ways. We can pass it directly, in other words, we send a copy of it, or we can pass a link to where that data is. So one way to think about that is comparing it to, you found something really cool on the internet. Passing by value means you printed a copy of it and brought it to your buddy. Passing by reference means you copied that hyperlink and sent them a hyperlink via email. So the same can actually be said for those returns. In some cases, we return not a technical value, but we may return a reference to a particular spot. We may not return anything, but we may later in the program reference that memory location because we know it hasn't changed, but we changed the values in there. But we're going to create our own methods, and then later on we're going to look at libraries in Python when we start working with Python, and we're going to start doing that next week. So before break, we're going to break out Python and start cranking out our own Hello World programs. So let's see where we're at time-wise. Okay, so one of the first things, there is a video if you haven't installed Python. Now, if you're here in the lab, Python is installed on all of these machines. Please make sure you have a local copy somewhere. It's cheap, free, and easy. The latest version, I think, is 3.3.4. As long as you're in the 3 version, there's really not a ton of difference. There's a few quirks and changes on these little dot changes. So we call the main number that 3, version 3, and then everything else is a version. There's not a ton of differences that we're going to immediately notice. There's some differences in some of the libraries that have changed a little bit, how to deal with IPv6 and some of these other things. So you'll need to make sure you have Python installed. If you have a homework assignment that you haven't gotten done, please ask and say, hey, I didn't get this one done. I know you've posted a solution. So I'd like to get everybody kind of caught up before we hit break. That's kind of my goal, and I know that a lot of that's been my fault the last couple of weeks, but I'd like to get everybody caught up to the idea of how do we get to enough knowledge so that when we start writing Python, it makes sense. So we're trying this method. We've tried it, trying hands-on before we talked about this, and that seemed to not always be a good thing. So now we're going to talk about the logic piece, and then go in and start writing Python. So if you would please make sure you have Python installed. I want you to look at the homework for Chapter 5, and there's an homework assignment for Chapter 6. So on Thursday, bring in questions about that homework, because we're going to first have a homework section, and then we're going to lecture about the last little piece that we're going to talk about in our book, quite frankly. And then next week, we're going to break out Python in force. And I think it's actually a little more interesting once you get your hands on that code. It's also sometimes where it gets a little more frustrating sometimes. So that's the game plan for the next week. All right, let me stop the recording here so we'll see how far along we are.